which is almost 100 times denser than atmosphere with sulfuric acid or acid rains and complex atmospheric constituents. Similar to that, there is a Mars which has a very thin atmosphere, 1/100th of atmosphere. So we don't know what made this atmosphere vanish on Mars and why it is so thick in Venus, and this must be understood. And we would like to do some specific scientific research to understand this. And of course, we will look at black holes. I think as we discussed, we have also looked at Sun. Okay, Sun is again another important member of our solar system, most important member, of course, the energy giver. And we want to look at Sun and look at its coronal mass ejection. Aditya L1 was launched specifically for that purpose in multi-instrument suite that we are observing Sun now. Now, again, there is another mission thought about like exosolar planets that we have to observe the exosolar planets and then make a measurement of the habitability of the planet by looking at the spectroscopy of the atmospheric aspect of the exosolar planet when they move through the front of the planet and the light that goes through the atmosphere. We can do the spectroscopy and understand the constituents in the atmosphere. This is one topic that currently being discussed. And there are other aeronomy related measurements called Disha, and there are many such scientific missions are in the discussion level. What I want to tell is every scientific discussion is related to the people who are available in the system. After this data comes, we need to understand this data, do research on the data, study it for over a period of time and make some conclusive conclusions. And this is the important aspect. It is not launching them. It is making sense of what you get out of it finally. And once you are able to have such type of people in the system who are researchers and data analysts, then we build the instrument. And also we need to build an instrument which will do the particular function. And once both of this come together, then we should be in a position to plan that mission and do it. And until then we don't do it, because simply launching and getting data is of no use. We don't have people who will be able to make a sense out of the data. So we are working with institutions, research laboratories, or educational institutions, and then find out to create the type of talent pool who will be able to help us to do these missions in the future. Got it? Okay, there is a question asked by, I don't know the name is not clear. The collaboration between HAL, ISRO, NAL for the design and development of hybrid electric propulsion will be used in rockets. Of course, we have been working with various public sector undertakings and labs like HAL, NAL, and many tests are being done, facilities are being utilized for this, for not only for the one you mentioned, but for many things. Our manufacturing, testing of many things, even our rocket design, NAL is an integral part. They do a lot of studies for us to do the aerodynamics, the flexible dynamics, they do combustion testing, etc. HAL is a long-term partner in building propellant tanks, structures, etc. So we continue to do that. Okay. There is a question from Samir Gupta. He asked again earlier a question. When does ISRO plan to publish findings of the data of the Aditya L1 and Chandrayaan 3 missions? Yes, this is a very, very difficult question because the data cannot be published. What you have to find out is what you found out of the data. What is the significant scientific outcome of the data? And data is already coming. I think Chandrayaan 3 data has been collected for 14 days. All the data is with us. Aditya L1 started doing the initial calibration of the instruments, and currently the calibration process is on. Still, data is still coming. And this data goes to the scientist and they are making some assessment, etc. But you have to collect it over long periods of time and then make systematic assessment of it. Then make certain conclusions. I will tell you one example. When Chandrayaan 2 was launched and the discovery of the hydroxyl molecule, the percents of water, it took so much of time, almost 6 months to 1 year also, because it was not very evident in the very first. But later analysis of the data after looking at it multiple times and making sense of it came much later. So this is the nature of the observations. So you have to be very patient enough to have scientific findings come out of it, but data is always accessible for people who are doing it and it is being made available to everybody. Okay, there is I think the time is up. We have spent almost 1 hour looking at the many of the questions. I think the number of questions are so large. I have selected only a few, even that I couldn't complete. But then I look forward to very interesting topics in the future. Some of them, the type of questions that people are asking, you heard, and I won't be answering most of them if those questions are coming again, because every session that we won't be able to answer the same question and same type of answer. So I would like you to look deeper. Of course, your interest to join ISRO is something very paramount. I think many of you may be still having no clarity on it. They want to know the path. I think that is one issue which you should have a little more clarity on helping you. And many of conditions, this will come on one-to-one type of interaction only. So looking forward to more questions and more interactions in the coming days.